there, two Ps. Welcome to the second lesson of your fifth unit on measurement, which is really just about 3D geometry. Today we're going to look at the equations for pyramids. So, first of all, our learning goal, you're going to be able to calculate the surface area and volume of pyramids, and you're going to use a variety of imperial and metric measurements. That is part of this unit is to use both of those units or systems of measurements. So that's why you're seeing some of the examples done in yards and inches and feet, and some of the other examples are in centimeters and millimeters, etc. Okay, so pyramids. Oops, that should say pyramids have any shape. Go back. So pyramids have any shape base, and then on the other end of the pyramid from the base is a pointy top, and then the sides are all triangles. Doesn't matter how many sides you have on the base of your pyramid, each of your sides are triangles. Okay, that was different from prisms in that all your sides were rectangles. So let's take a look at how to find the volume um, of a pyramid. So in general, to find the volume of a pyramid, you divide the volume of the matching prism by 3, which is kind of cool. So why is this? So I'm just going to play this short little video of showing how this works. So you can see the triangle and the square or the cube have the same height. But if you take the triangle, it takes 1, 2, 3 of them to fill up the cube. And it's going to be the same with any prism of the same height. So this is a triangular base prism with the same base pyramid, and it's going to take 3 of those to fill up the prism. And so this is a literal example of volume. I'm going to pause it there because it has more and more examples of that. So isn't that pretty cool? So you could watch that video on your own again, but basically, if you have the same size base prism and pyramid, it'll take 3 of the pyramids to fill up the prism. So that's why the general formula for the volume of a pyramid is the area of the base times the height divided by 3. Because if you remember, the volume for the prism was the area of the base times the height. So now we're doing the same thing divided by 3. So here's an example. We have this triangular base prism. You can see the bottom is a triangular base, and then each side is going to be triangular. It tells us what the area of the base is. It's 8.7 centimeters squared. And then our height of the pyramid, the height of the pyramid is 9 centimeters. So it goes from the base all the way to the top point. This is called the height. This right here that measures the height along the side of a triangle, that is called the side length, or the slant height, I should say. That's called the slant height. And we're going to use that when we're calculating surface area. Okay, so our area of our base is 8.7 centimeters squared. Our height is 9. Then we're going to divide by 3. So 8.7 times 9 divided by 3 gives us 26.1 centimeters cubed. Again, we're going to use the cubed because um, it's 3 dimensions, right? We have area, which is already centimeters squared times another centimeter, so centimeters cubed. Remember, volume always has cubed units. If we want to find the volume of a square pyramid, this one, it doesn't tell us what the surface area is of the base. But because we know it's a square, we know each side is 12 and this side is 12. And to find the area of that base, it's going to be 12 by 12. And then we're told the height of the pyramid is 16. So we do 12 times 12 times 16 divided by 3. If you put that into your calculator, you should get 768. And then the units are centimeters cubed because we have units in centimeters. And if we do centimeters times centimeters times centimeters, we get centimeters cubed. So let's take a look at surface area. So just like with before, the easy way to determine the surface area of a pyramid is to imagine or make a net. So you can see this is a triangular base pyramid. This would be the base. And then if you fold up each of these 3 sides, you will get a triangular base pyramid. So that's what I just said. And it's that shape is called a tetrahedron. Don't worry about those types of words. I'm not going to test you on that. So to calculate the surface area, you can imagine you just find the area of all of the triangles and add them up, just like we did with the prisms. So let's do an example. So if we have surface area of a triangular prism, well, look, we're told the area of the base here. It's 43.3 meters squared. And now we have 3 of the same face. The base is 10, and the height of this side, this is called the slant height here, but it helps us find the area of one of these sides. So remember, the surface area of a triangle is 1/2 times the base length times the base, or sorry, times the height of the triangle. So if you were to make this into a net, we're going to have a triangle in the middle and then 3 triangles on the outside. And if you calculate 1/2 times 10 times 12, you get an area of 60 for each of our 3 sides. So the base is 43.3 meters squared, and the triangle is, there's 60, and there's 3 of them. So 60 times 3 is 180. So we get a total of 223.3 meters squared. Okay, remember meters squared when you're doing area, because you're only working with 2 measurements at one time. Now, what happens if you don't have this slant height and you're given the height of the pyramid? That takes an extra step. So let's look at this square base pyramid, which we had before. We still can find the surface area of this, but there's one thing we need to find first, because we can find the surface area of the bottom of the pyramid, the base, but how do we find the surface area of each of the sides? Well, the first thing we're going to do is make a net. So we have our square base, and then we have our 4 sides of our pyramid. So each of these sides of the square are all 12. That means this is 12 here, but we need to know this measurement in order to calculate the area of each of these triangles, right? So how can we do that? Well, let's take a look back at this diagram here. This side here is this measurement here. Now I'm hoping you're seeing this. If you connect this to this, we're gonna have a right angle triangle. So let's just go forward. And if you connect them, check this out. We now have a triangle with the hypotenuse and the sides. Now we know this height is 16. How do we know what this length is? Well, we know the base of the square has a distance of 12 centimeters, and this is half of it because the point will go right into the middle of the square. So half of 12 is 6. And now look, now we have a triangle set up with the hypotenuse we don't know, but we do know the two sides. How can we find this? This should take us back to our first unit. We're going to use that Pythagorean theorem to find this length, to find C. So remember, C squared equals A squared plus B squared. A and B are the two side lengths. So C squared equals 16 squared plus 6 squared. C squared is 256 plus 36, and we're going to add those together, getting 292. But don't forget our last step to find this C is to take the square root of that. Square root of 292 is about 17 centimeters. And that makes sense because remember the hypotenuse is always the longest side, so it needs to be longer than this side. Okay, now that we have that, we can use that and the fact the base is 12 centimeters to find the area of all four of our pyramid sides. So let's go here. Okay, so this total surface area is the surface area of the base plus 4 times the surface area of the triangles, because there's 4 triangles. So the surface area of the base is 12 times 12, and plus 4 times 1/2 12 times 17. And I'm going to change that to 17 so that we know. Here we go. Let me put those back on, put that. And now we're just going to plug this into a calculator. So 12 times 12 is 144. And if you do 4 times 1/2 times 12 times 17, we get 408, and then our last step is to add them together. So we get 552 centimeters squared. So that's how you can calculate the surface area of a pyramid if you have the height. Remember, you need to find that slant height in order to find the area of these triangles. Okay, so that's it for the lesson. I have put up 2 practice sheets for this lesson, one on surface area and one on volume, and the answers are on the handouts. If you have any questions, please contact me through Brightspace using the instant message or the email. Once you're done that and you feel good with that, you can go ahead and try the 5.2 quiz on Brightspace. Okay, that is it for today. Next time we'll be doing cylinders, which will be a little easier. Okay, see you next time. Bye-bye.